Hello, welcome back. We're ready for section 2 of chapter 2. Doing part 1 today. This section is all about synthetic division. This is something that you got introduced to in Algebra 2. We're going to start off by multiplying two factors. The first factor is a binomial, x minus 2, and the second factor is a trinomial, x squared plus 6x minus 4. So just use the distributive property, x cubed plus 6x squared minus 4x. Now distribute the negative 2. It's negative 2x squared minus 12x plus 8. Now combine like terms. So that's x cubed plus 4x squared minus 16x plus 8. And that is the product. A product is what you get when you multiply two factors. Now what I want you to do is take the product and divide it by one of the original factors. For instance, if you took 2 times 3, you would get 6. 6 would be the product. Now take 6 divided by 2. Well, you get 3. When you take 6 and you divide it by one of its factors, you get the other factor. So if we divide by x minus 2, we should get the other factor. Alright, when you're doing synthetic division, your divisor, what you're dividing by, must be linear. In other words, the degree must be 1. And in that case, we're good here because it says x to the first power. The leading coefficient of the divisor must also be 1. So we're good there. Those two conditions must be met in order to do synthetic division. That's important. So let's do some synthetic division. You want to? Alright. So what you do here is our divisor was x minus 2. That's what we were dividing by. I'll put a little division symbol there. If you're dividing by x minus 2, then what you're going to put in the hoopty is actually the opposite of minus 2. You're going to put 2. And that's because when you take x minus 2 and you set it to 0 and you solve, the value of x that makes that true is positive 2. So remember, this is really the same thing as direct substitution. So we're directly substituting positive 2. And then what you put are your coefficients. Now, your coefficients are 1, 4, negative 16, and 8. And notice that you're not missing any. So let's put 1, 4, negative 16, and 8. Leave a little space. Hopefully you remember what to do from the last section. Drop your 1, you get 1. Take it times the hoopty. 2 times 1 is 2. 4 plus 2 is 6. 2 times 6 is 12. Negative 16 plus 12 is negative 4. And 2 times negative 4 is negative 8. And you get 0. Alright, now that's as far as we got in the last section. But in this section, we take it one step further. If the polynomial you were dividing by was a cubic polynomial, then what you've done right here, see this cubic? You've actually depressed this polynomial to a quadratic. And here are the coefficients of your quadratic polynomial. Quadratic starts with x squared plus 6x minus 4. So it was x cubed up here, now it's x squared. It's depressed. It lost a degree. This is called a depressed polynomial. Depressed polynomial. Or, since it was the answer to a division problem, we could also call it a quotient. The important part I want you to see is that x squared plus 6x plus 4, if I blow this back up, here it is right here, see? It's what we had originally when we multiplied. It was the other factor. Cool. Alright, now we're gonna do this with long division as well. Instead of just synthetic division, we're gonna do long division. Okay, everybody should remember long division. Now, long division, you can use it anytime, but you must use it with non-linear divisors. So, like for instance, if you're dividing by something that starts with x squared plus dot dot dot, that's not a linear divisor. What you're dividing by is not linear, so you must use long division. Okay, so what you're dividing by goes on the outside. Your dividend, what you're dividing into, goes on the inside. Now, it might help you to do an old school long division problem over here. So 2,875 divided by 23. Okay, so here we go. How would you start this problem? You would say, okay, 23 goes into 28 one time. So here's what we do. Okay, x goes into x cubed how many times? What do you have to multiply x by to turn it into x cubed? X times what is x cubed? Well, it's x squared. Remember, you lose a power here, guys. X times x squared is x cubed. Okay, go back over here to the red one. Now you would take 1 times 23 and you'd put it right here. Okay, bounce over here. Take x squared times x, that's x cubed. But you have to distribute it to the other guy too. X squared times minus 2. That's minus 2x squared. Okay, go over here. What would you do next? You would subtract 28 minus 23 and you would get 5. So you're going to do the same thing over here, but be careful. When you subtract a binomial, you're subtracting both of them. So x cubed minus x cubed, they go away. But this minus actually turns him into a plus. So when you subtract 4 minus negative 2, you get positive 6x squared. Okay, what we did there was subtract. Now go back over to the right side. Do you know what to do? You drop the 7. So we're going to drop the negative 16x here. It's the same process. And now you say, okay, how many times does 23 go into 57? 2 times. Okay, so go over here. How many times does x go into 6x squared? 6x squared. X into 6x squared, you need a 6. And x into x squared, you need another x. Okay, jump over to the right side. Start over. Take the 2, multiply it. 2 times 23 is 46. Go to the left side. 6x times x, 6x squared. 6x times minus 2 is minus 12x. Okay, go over to the right side. Subtract them. That's 11. Go over to the left side. Subtract them. Careful here. Put him in parentheses because you're going to have to change your signs. He becomes negative, so they go away. That'll always happen. He becomes positive. Negative 16 plus 12 is actually negative 4x. Okay, next step over here. Drop your 5. Next step over here. Drop your 8. Okay, how many times does 23 go into 115? I'm pretty sure it goes in exactly 5 times. Okay, how many times does x go into negative 4x? Well, to turn x into negative 4x, you have to multiply by negative 4. Distribute your 5. That's 115. And when you subtract them, you get a remainder of 0. That's nice. That's because 23 times 125 is 2,875. Over here, distribute the negative 4. So that's minus 4x plus 8. And when you subtract that, your signs are going to change. He becomes a plus, he becomes a minus, and they both just wipe out, and you get a remainder of 0. R0. R0 is what that says. That means, just like in the last problem, our x minus 2 times x squared plus 6x minus 4 is equal to x cubed plus 4x squared minus 16x plus 8. Alright, I'm ready to move on from this problem because I have done it enough times. Let's do some practice. Alright, I want you to divide 2x to the 4th minus 15x squared minus 10x plus 5 by x minus 3. And I want you to use whatever method you want. What method should we use? Well, we have a linear divisor with a leading coefficient of 1. Those sound a lot like the conditions for synthetic division. So I think maybe we should use synthetic division. So set up your hoopty. Now, if x minus 3 is the factor, then that means positive 3 goes in the hoopty. Did you catch that? That's because 3 is the value that you'd be plugging in. Now we need our coefficients. Make sure you're not missing any. 2. 15x squared. Uh-oh, red alert, red alert. What are we missing? Oh yeah, we're missing that 0x cubed, aren't we? Careful. Alright, so 0, negative 15, negative 10, and 5. Oh, and just so you know, if you're doing long division instead of synthetic division, you have to put the zeros in there as well. Okay, so 2, 0, minus 15, minus 10, and 5. Draw your line, and let the fun begin. Drop the 2. Times by the hoopty. 3 times 2 is 6. 0 plus 6 is 6. 3 times 6, 18. Negative 15 and 18 is 3. 3 times 3 is 9. Negative 10 and 9 is negative 1. 3 times negative 1 is negative 3. 5 and negative 3 makes dos. Makes 2. That is called the remainder. The remainder is what that is. So we would write our answer like this. Remember, we started off with x to the 4th. We started off with x to the 4th. That means that the depressed polynomial must start off with x cubed. So we would say, okay, 2x cubed plus 6x squared plus 3x minus 1. And then to write a remainder, you put plus 2 over what you divided by. What factor did we divide by? X minus 3. That's just like saying, you know, the remainder when you divide 14 by 9 is 1 and 5/9. 1 and 5/9. It's the same idea. Alright? Let's make a little closing statement here to finish off this problem. We say, therefore, 2x to the 4th, and this is what we started with, minus 15x squared minus 10x plus 5. That's called the dividend. The dividend. The dividend. That's what we divided by. Divided by. We say that's equal to the divisor. I'm sorry. The dividend is not what we divided by. It's what we divided into. Sorry. It's equal to the divisor times the answer. In a division problem, what do you call the answer? Starts with a Q, ends with a quotient. That's right, I heard you. I heard you. That's the quotient plus 2. And the 2 is called the remainder. Remainder. It's just like this. So if you have 25 and you divide it by 3, that's 8 remainder 1. Okay, so we say, well then 25, what you divided into, the dividend, is equal to the divisor, what you were dividing by, times 8, the answer, plus 1, the remainder. It's the same idea. This is a very important concept that's going to show up on quizzes and tests. This idea of dividing by a divisor, quotient, remainder. I might give you 3 of the 4 and say, set them up in this formula and find the 4th one. Okay, so this leads us right into the remainder theorem. When any polynomial, p of x, is divided by some factor, some linear factor, x minus a, the remainder, what you're left with, is always whatever p of a is. In other words, it's always what you get when you plug in a. So check out this example. Find p of 3 for this. So it'll be 2 times 3 to the 4th minus 15 times 3 squared minus 10 times 3 plus 5. And when you do that, you get 2. That means p of 3 is 2. Well, the remainder theorem says that that will be the remainder, the leftover. It's also the y value when the x value is 3. Well, let's check it out. Okay, so what would go in the hoopty? Well, remember, if x minus 3 is the factor, positive 3 goes in the hoopty. If x plus 3 were the factor, negative 3 goes in the hoopty. So if they say just find p of 3, you don't change the sign. But if they say divide by x minus 3, you do change the sign. Okay, your coefficients were 2, 0, careful because you were missing 0x cubed, minus 15, minus 10, plus 5. Okay, we better get a 2 down here because that is our remainder. Let's see if we do. Drop the 2. 3 times 2 is 6. 0 and 6 make 6. 3 times 6 is 18. Negative 15 and 18 is 3. 3 times 3 is 9. Negative 10 and 9 is negative 1. 3 times negative 1 is negative 3. And dun 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 dun. 5 minus 3 is 2. Check it out. Isn't that sweet? Okay, got a little proof that I want to do for you guys. I know you love the proof, so put proof. Let's prove the remainder theorem. We already said that p of x, any function, is equal to a divisor. So this is what times the quotient plus the remainder. That's dividend equals divisor times quotient plus remainder. We just wrote that. Okay. Well, I want you to do this for p of a. P of a. That means everywhere you see an x, you put an a. Just like so. Alright, well, wait a minute. A minus A is just 0. Well, wait a minute. 0 times anything, that's just 0. So I get 0 plus r. Well, and 0 plus r is just r. There you go, folks. You just proved the remainder theorem. When you plug in p of a, you get the remainder. Well, p of a gives you the remainder. There's your little proof. Alright, I'm going to let you go. I want you to divide x to the fourth minus 8x squared plus 5x minus 1 by x plus 3. Now again, I gave you a linear factor. So you can use long division, but I think it makes more sense to use synthetic division. What would go in the hoopty? We're dividing by x plus 3, so we put minus 3 in the hoopty. Coefficients are 1. Careful here, we're missing 1. We're missing x cubed. So 0, then negative 8, 5, and minus 1. Alright, drop your 1. Negative 3 and 1 is negative 3. 0 and negative 3, negative 3. Negative 3 and negative 3, 9. Negative 8 and 9 is 1. Negative 3 and 1 is negative 3. 5 and negative 3 is 2. Negative 3 and 2 is negative 6. Ding, 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 negative 7. Sweet. So, answer, when you divide, careful, you depress the polynomial. So it was x to the fourth, but now it'll be 1x cubed minus 3x squared plus x plus 2 minus 7 over what you divided by, because the 7 is the remainder, and we divided by x plus 3. We divided by x plus 3. Divided by x plus 3. Okay, alright, I want you guys to try the last one. Here it is. Do x cubed plus 5x squared plus 5x minus 2 divided by x plus 2. Careful, what goes in the hoopty? It's negative 2. Alright, your coefficients are 1, 5, 5, minus 2. I want you all to try that one. Pause the video, try it, see how you did. Okay, let's see how you did. Welcome back. So drop your 1. Negative 2, 3, negative 6, negative 1, positive 2, and 0. So your solution, your quotient would be x cubed, no, x squared, because we started with x cubed, plus 3x squared minus 1. Remainder, 0, but you don't have to put the remainder 0. Okay? Let's just put this, the whole picture together. Therefore, that means that x cubed, what we started with, the original cubic polynomial, we started with a cubic polynomial, that's equal to what we divided by, the quotient, I'm sorry, the divisor, x plus 2, times, I got to put it down here, you guys put it next to the side, x squared plus 3x minus 1 plus 0, the remainder, plus 0, the remainder. Let me write that out for you. That means our original function, p of x, that's what we started with up here, is equal to what we divided by, right here, x plus 2, or, x minus a, times the quotient, the answer, which is, q of x, plus the remainder, which is 0, right there. Okay, so that's all I have for the first part of section 2. So, hope you enjoyed the remainder theorem, and come back for part 2 to talk about the factor theorem. Have a great night. I'll catch you later. I'm out.